Mark, how the hell are you, sir?
Fine, thank you, sir.
Good, glad to hear it. Um, have you been following all the news on the UFOs and or the UAPs lately and everything?
A little bit. I try to, have do a little searching in the background and stuff, but mainly I've had a lot of activity going on with my theory and writing papers, and so I haven't really had a chance to, unless somebody sends me some link or something, some especially photographs or movies, videos of something. I haven't really kept up with everything that's been going on lately.
Does your theory fit in with the propulsion behind these vehicles or proposed propulsion?
Yeah, I there's so many proposals out there for
True.
how are propelled. Basically, according to my theory and what I have observed by reading books on the subject and listening to other people talk, and especially the old discussions concerning the U.S. Air Force and when they used to have Project Blue Book and when they would investigate landing sites, it all revolved around that the UFOs were emitting strong, very strong magnetic fields. So I realized that when I was a teenager, and so it was always in the back of my mind that somehow magnetic fields are the cause of anti-gravity, or some special anti-gravity field has a byproduct that is a magnetic field. And over the years, I narrowed it down to saying, no, it's the magnetic field that must be causing an anti-gravity field. So I had to figure how that worked. And it took me many decades of thinking until I finally understood exactly how a magnetic field could provide anti-gravity and propulsion. So in my book, that's what I have went into great detail discussing and describing the mechanical method that's necessary in order to create an anti-gravity field. And it really is all about creating a very powerful magnetic field, which causes space to be stretched, because the magnetic field is really a rotation of space. And so when the space is forced to rotate, which in my theory, space is I call it the ether, which is what they called it back in the early parts of the 19th and 20th century. Um, I determined that the ether was real and true, and I had to go back in history and correct that problem that they came up with a misinterpretation of a famous experiment, realizing that the space that we're in, this universe, is the only real object there is, and everything is made from that object, and it's a continuous field. So it's a quasi-elastic solid, and from that, the fields of force I was able to determine were really from this continuous field. So, like Einstein said, when he decided that he needed to come up with a unified field theory, was that somehow electromagnetism and gravity emerge as aspects of a single fundamental field. So I said, well, it must be that the single fundamental field that he's talking about is the ether. And in the end, he made speeches and confirmed that is indeed the case. And so magnetism, electrostatic fields, and gravity are just different types of bending of the space of the ether. And so then it became a matter of figuring out what was gravity. And so in my book, over the years, I was able to determine the central cause of gravity, the mechanical method that creates it. And once I understood gravity, then I knew I could go after anti-gravity, because it's just the reverse. Gravity is a contraction, so anti-gravity is a simple expansion of space.
Now, you say this ether, it can be stretched, correct?
Yes.
Can it rip? Can it tear?
it can be affected in such a way. Well, there's two answers to that. So let's go over both. If you want to travel faster than the speed of light, you don't really rip it or tear it, you reduce it down to almost zero. And how do you do that? By stretching it. So if you stretch any material, like silly putty, you stretch it, eventually it stretches into a very small, thin fiber. So what we got to do with space is you just stretch it with a magnetic field, which reduces its permittivity and permeability, which are properties of space. And if you reduce these two, you will increase the speed of light. And that's already common knowledge that was revealed to us by James Clerk Maxwell, who discovered that the speed of light was determined by C equals 1 over the square root of permeability times permittivity. Permeability being something that has to do with the way the magnetic field forms in space, and permittivity, the way the electrostatic field forms in space. So if you master space, if you bias it, you can control how fast you can go. You can move faster than the speed of light. So what we do is we stretch space till we reduce permittivity and permeability to almost zero. And when you do that, you wind up being able to go 10,000, 50,000, 100,000 times the speed of light. So we know theoretically that this is already possible, because in my research, I've found people who have material scientists and physicists who have made a left-handed material, metamaterials they're called, that reduce permittivity and permeability within the material. And they're claiming the speed of light is infinitely fast. This is on the internet, on ResearchGate and journals such as that. So that backs up what Maxwell says, and it's backing up what I'm saying. So that's how we have to go or do in order to go beyond the speed of light. So in one sense, well, okay, we stretch space, we reduce permittivity and permeability, we are allowed to go as fast as we want, as long as we bias the space. So our spaceship within this bubble of strong magnetic field, a gradient field, can go faster than the speed of light. But can you tear space?
Right.
Now that's kind of interesting. I don't know if it's an actual tear, but in is it the last chapter in my book, or the second to the last chapter, I talk about stargates. And what you can do in this case is, again, you use a very powerful electromagnetic field that uses metamaterials that form into something called a fractal lens. Now you shine the light or the electromagnetic energy through this. This would be in the frame around the Stargate. And when it comes out the other side, it's moving faster than the speed of light. So it creates an electromagnetic shock wave in the space around the frame of the Stargate, which allows you to tune that space in such a way as to create a portal, an opening into other dimensions, other realms, other times. So that's as close as you can get to tearing space apart.
Okay. Fair
Those
enough.
are
I
the
mean,
two ways.
fair enough. You mentioned bubbles. Is that basically just you're riding around in compressed air, and that's basically why the objects the Navy's been witnesses don't make a sonic boom? Is that what it pretty much implies?
Yeah. Let's go. There's a lot of important things going on. When you create the slip wave is the device or the method. You're biasing space with a magnetic field, a gradient field. So you have, like at the front of the ship, you have a strong magnetic field. Let's say it's a oblong shaped UFO, a Tic Tac, all right? So at one end, you have these coils going around, the concentric coils going around the Tic Tac, right? So you turn on the one coil, very strong, powerful current going through it, but the next coil is even stronger. And the next coil after that is even stronger magnetic field. So you build a gradient, a cone-shaped, very powerful field, and that gives you not only anti-gravity, but propulsion. And that's what's needed to move the ship. Now you're inside the slip wave now. All the occupants, everything is inside that bubble, the slip wave field, which is very important, especially when you go beyond the speed of light. But the benefits of using this type of field is that when you stretch and pull the space apart by causing it to rotate powerfully, you get a benefit of the cancellation of inertia. And so what happens is, even though you're in that ship moving at 50,000 miles per hour, and then you decide you want to make a left turn or something, and you do a 90-degree turn, if you did that without the slip wave field around you, you would experience bone-crushing inertia. You would be killed immediately. That's why jets can't do. People, you can only take so many G-force.
I think 14 rips the plane apart, right? 14 Gs at that part, it's just like gone.
It's not much, and it's, if you're moving 50,000 miles an hour and you make a sharp right turn, the jet would fly apart. Your bones would crush you. Your blood would stop flowing. You would be killed. It's called. So what you have to be careful of when building these kinds of ships is you have to make sure there's no inertial leakage. That field must encompass everything. And you'll notice in most
3D print it.
Pardon?
Maybe you could do something like that if you 3D print it. Is that what you're talking about? The structure itself?
No, the structure itself has to be a simple geometry. If you notice, like the Tic Tac, there's not really much of anything extruding from it.
Right.
If you go too far beyond the basic geometry, too far, some of it may poke beyond the powerful magnetic field, and that will experience inertia. And if you're in deep space going beyond the speed of light, that will have very catastrophic problems. It will contract that area that's not protected. It will contract to a flat pancake. It will increase in mass to the point where it'll form a black hole if it's not protected by the slip wave field. So now the other point you wanted to make is why there's no sonic boom. It's because that magnetic field that's surrounding that ship rarefies the air.
Okay.
So what it does is thins it out all around it. So the sonic boom effect is kind of negated because it's like moving in a bubble, sort of.
I gotcha. Yeah.
Yeah. So the air is, just kind of pushed out of its way. And it would take a physicist with some, me describing that to get the right words. I say rarefying. I think that's the closest to exactly what's happening. Somehow that air is being thinned out so much, it's like it's moving in a vacuum. And the air, is just rarefied to the point where it's hardly notices the displacement of itself. When an object moves through the atmosphere, it displaces the atmosphere, right?
Sure.
Well, there's a minimal amount of displacement, I guess, because the air is rarefied around the ship by the magnetic field.
I got you. Do you think the rumors are true that I've heard rumors that, do you think they've mastered gravity back in 1951? The government.
Yeah, somewhere starting. I think starting in 47 when they in New Mexico, when they got that first ship, they reverse engineered it, and by 51, probably somewhere in there, either by talking with some other aliens that they might have captured either at the Roswell site or some site thereafter, the U.S. government probably knows everything I'm saying that's in my theory already. I'm sure that the aliens that they've talked to have explained how these things work and how the anti-gravity system works. And so, yeah, they know about gravity, and they simply classified all that information, especially anti-gravity, because, well, why would they do that? Well,
Right.
quite simply, it gives the United States of America and the Air Force a strategic military advantage. And
Absolutely.
yeah, they're not going to let that go
No.
easily. Only when they feel that the other side already knows or somehow has, done the same thing. Eventually, they'll say, "Well, they know, and the Russians know, and Chinese know," and there's a good chance the Chinese already know too.
Even with the even what we saw this past week with the with their first stage is coming down what willy-nilly, into our atmosphere and landing what just where did it end up landing off the coast of Sri Lanka or something?
What's this now? I'm not aware of what.
Oh, the Chinese sent up their first part of the their ISS, I guess.
Oh, okay.
And their first stage, you know how we control land and bring them back to orbit and all that's, well, they didn't, I think they didn't do that. I mean, obviously we didn't do it, when we first started learning either,
Right.
we didn't master it either, but still you think they would know by now. And this is the second time. I remember the first time I think it landed in Australia. So this is like the second time they did that, and I think in a century, or no, in like a decade. So it's just weird. So
It
that makes me to
actually,
believe that did China really, do you think China does have this, or Russia?
I think China has it only because of what happened in the Vietnam War, where our our boys on a river encountered two UFOs and fired at the UFOs, and the UFOs returned our fire with our own ordnance, somehow turning the bullets and rockets around and using them against us. And since they decided to take sides in that particular war over there, in this one particular instance, um, I would say either it's a very strange thing that they would take sides against us, although we did fire at them. So I guess that gives them a good reason to return the fire,
Right.
or that the China was testing out their technology and they wanted to see how it worked in a battle situation, and it worked very well. We got beat down pretty bad when we tried to shoot at them. We
Wow.
lost some people, and they reversed our rockets that we fired at them and hit a ship out at sea with them. So it looks like, from what I can see, that China may already have anti-gravity technology as well.
Okay.
So it's like a virus that's going to spread eventually.
Right.
As these UFOs come down in different countries, U.S. has been pretty good at going into other countries and grabbing them, but there's certain areas they can't get into, like Russia and China. And so there's a chance, because these UFOs fail at a fairly regular frequency. They've crash landed many times. Usually if they go through thunderstorms, it's real bad idea for if you're flying a UFO, by the way. Um, they encounter maybe some lightning or something, and that brings them down. And there's no glide aeronautics or anything with UFOs. They fall like lead stones.
No
And
ejection parachutes.
and now their plan is they just crash.
Just crash. I mean,
Yeah.
there's so many. I mean, we go so many different ways right now, but oh boy, another thing you think you need is a room temperature superconductor for that aircraft, right? Something along those lines. And believe it or not, I've have you seen the Navy patents on that, whether it be true or not? It's just something that's like Dr. Caesar Pius um sent some patents through the Navy, and they said that the actual room temperature superconductor is actually able, and the other one was that basically looked exactly like the Tic Tac, and they said that was no, I'm sorry, this was the room temperature superconductor was operable, and the Tic Tac device was enabled. I think they said abled. I think they said so, but so
Mhm.
apparently, I mean, all the pieces are come together to say maybe the Tic Tac could have been ours.
Well, I know the Air Force was into many years ago. I did internet searches to see if the Air Force was interested in temperature superconductors, because they needed powerful magnets, and high magnetics. They were involved with our, at FSU and some of these other places where the high magnetics labs are. They were heavily invested in all those, and they were giving money to anybody that had any sort of close idea about how room temperature superconducting materials might work. So, and they were looking at one thing nobody else noticed really much was very efficient power supplies. You need a lot of current to build these magnetic fields, a lot of power, and it has to be in a small space, like the size of maybe a basketball, or maybe a little bit bigger, so that you can fit it in the ship and generate the megawatts of power needed to drive these coils of superconducting wire. So that, sure enough, the Air Force was all over the place looking at these technologies, which tells me they're building UFOs. They're planning, or they're already building, and they're looking for better stuff to build it with. So now the only question remains: did they get the supplies from aliens by making friends and so forth, and maybe making some sort of deal that we don't know about?
Don't want to know about.
Or were we able to eventually on our own develop room temperature superconducting wire? That would be a huge thing in the news. But
Really?
if it were to happen, it's going to be classified for the same reason that anti-gravity is classified, because they don't want people playing around with high powered magnetic fields. Because eventually, like Eugene Poklenov, they're going to see that strong magnetic fields have an effect on gravity in the area. And then, one thing will lead to another, and eventually people outside of the government will discover how to make an anti-gravity field by using, magnets. Basically, I think it's magnetism along with moving the field and rotating it in some way seems to enhance the anti-gravity effect. And that's what I will be eventually asking people to do. I'm working on not only a research paper that defines gravity and how it works, the origins of mass, that's the unified field theory. I'm also working on a PowerPoint presentation that goes more into the anti-gravity aspect and the experiments that we need to get people to do. You and I, we need to get people to do experiments with magnetism and really quantify how it affects gravitational fields, how we could use it for shielding and how we can use it for propulsion. That's the next step. We got to wake up the physicists outside of the government. The ones inside that work for the, Area 51, they know. But it's the other guys that are still playing with particle accelerators and looking for particles, wasting their time basically in this avenue. They need to get into this stuff, because where the action at for the future is all about anti-gravity. It's not about finding more particles and coming up with a unified field theory based on a particle-to-particle interaction, which is a quantum field theory kind of a thing. It's never going to be about that. It's a wild goose chase. It's never been about a particle-to-particle interaction. The forces of nature like gravity and magnetism, it's about a particle-to-space interaction. The motion of particles moving through space cause space to bend, either magnetically or gravitationally or anti-gravitationally. That's where the unified field theory is at, and that's where I'm at right now. And I'm about to release a paper that will prove the origin of mass and gravity and inertia. It all comes from the same thing, just like Einstein thought.
You said something interesting too, how some of these physicists out here are wasting their time doing other things, which kind of makes me think of people like Elon Musk and how they're sending rockets up. And somebody as smart as that guy has to know about this. So why is he wasting his time on a fleet that's going to be obsolete in maybe like 2 or 3 decades?
Well, I don't know what he knows. Without talking with him myself and asking some questions, I don't know. Maybe someday we'll meet. I hope so, because he's a visionary.
Sure.
And he could be the kind of guy that eventually would start, a program, and maybe he has and hasn't talked about it, because there is a lot of companies doing anti-gravity research. I have a list somewhere. It's a list about this long of all these, aeronautic companies, space, that are doing anti-gravity research. Of course, they don't report to anybody in the public eye, just the government, and nobody's saying if they're advancing at all or anything. It's all hush hush. And maybe he knows about this too. But there's, obviously money to be made in the rocket field, because the government still is willing to spend billions building rockets to go into outer space, which we could move the same amount of material into space for pennies, microscopic pennies on the dollar, to what it costs to move up, let's say 500 pounds of material into outer space and to build a space station or whatever. We could do it at a fraction of the cost using anti-gravity technology. You could build a ship, let's say the size of 2 football fields, and carry up thousands of pounds, because once you turn on that field, everything inside becomes weightless, and it just could be floated right into outer space, deposited at whatever speed it needs to be so it's in orbit, and done very inexpensively, instead of putting all these rockets and and all the risk involved.
A lot of
Will
risk.
be much lower risk, much more cost effective. Yet the government wants to keep this stuff so secret, keep that military advantage, that they're still allowing us to keep building rockets and keep designing. And
Choking on it, basically. I don't know. Have you ever thought about our Earth, like our Earth, like us being stuck between two oceans, like the Earth, the oceans on the Earth, and then space being an actual ocean, and we live on land and almost between two oceans? Do you ever think of space like as an ocean? Can it be compared as space being like an ocean almost?
well, it's definitely not a liquid, so I don't think of
Right.
it as an ocean. Maybe in a way, what's the word? Romantically speaking, or
Okay.
as it's the new frontier, it's the new ocean. Like in the olden days, we sailed across from Europe to and discovered America, a whole new continent that the rest of the world didn't even know about. Well, I look at space as just the medium that is. I look at it for what it really is, and what I've discovered it really is, which is a quasi-elastic solid, and it's a thing that basically defines what distance is. Without the real substance being there, there would be no distance, and it would take no time to traverse. In the ocean, you travel across it because there's an ocean there. If there was nothing there, it would take zero time to cross the ocean because there's nothing there. Distance equals rate times time. If the distance is equal to nothing, then it would take no time to cross it. But space is obviously not equal to nothing, because it takes time for light to traverse it. That's a clear indication that space is a something. And not only that, but the light particle itself is a transverse wave. And we know for sure transverse waves travel only in solids. Space is a solid, just like I'm telling. The evidence
Right.
is there. It's just been suppressed. It's been ignored. The physicists know this stuff. I mean, Einstein talked about it in his Leiden speech. He said it right there. And light is a transverse wave, and they, I think he said it only travels in solid, or primarily travels in solid. So all electromagnetic particles, all particles are transverse waves. So they are existing, made up, consubstantial with the medium that they exist within. They're just bendings of that medium. And so I look at space as one big, gigantic solid that apparently probably goes on forever, infinitely. Hard to get around that. But Einstein described it more as like a unbounded, finite but unbounded system. And that makes sense because particles can't ever get to an edge to unwind. Basically, particles are twists of space and they're persistent. You can't destroy them. You can change them from more energetic to more massive, but you could smack them together and they don't destroy. The conservation of mass and energy remains no matter how hard we smash them together. There's no way for these vortex type shapes to unwind. So it is kind of a finite but unbounded system, sort of like you could think of as like a rubber band is a finite but unbounded system. So if you were to take the rubber band and cut it, which you can't do to space, but then twist and then seal it again and leave the twist in the rubber band, it'll never come untwisted because there's never an edge for it to unwind into. And it's the same way with particles. So that's the way I look at space. And, you can romantically look at it as the new ocean or the frontier that we're going into. And I'm fine with that. I mean, I kind of think of it that way too. It's the new, much bigger ocean, but it's not a liquid. It's just a solid material that we travel within.
Have you ever seen anything weird like a UFO or anything?
Yes. Oh, yeah.
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 Mm.
I saw them right outside my house. I saw them when I lived in Miami many years ago. It made the papers the next day because this was in the 70s. In Miami at night, which was when the UFOs were spotted, the night sky, there's really not much stars, if any at all. There's the moon. Maybe you'll see Mercury or Venus, maybe Jupiter, but beyond that, the light pollution is enormous. And when the humidity's up, if there's anything up there, you see an airplane, you'll see that moving across the sky. But when UFOs appear, they move weird. And the UFOs I saw that night were bobbing up and down. One was going down, the other one's going up, and they're kind of doing this. And there was about 7 of them, and they were going doot, 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 and they were bobbing up and down. And eventually, each one went up straight up, and it was gone, and the show was over. So I saw them back then, and I saw one out in front of my house around 3:34 in the morning. I got up. I usually get up then to get a drink, and I was in the kitchen getting a drink, and I saw all these red and green lights. And I said, "Wow, there must be a cop car out. There's a road in front of my house and a lake beyond that." And so I turned to look to see where the police were, but there was nobody on the road at all. But there was something over the lake, moving at about 1 or 2 miles an hour, slowly moving back and forth. And it had red and green lights on it. And then eventually they all turned red. And then I says, well, I gotta get somebody else to see this, to witness this. So I woke up my wife and I got her into the porch and we looked for a while. And we saw it over the lake, and it was as big as our house. And then I asked her after it was over, what did you think? And she did not believe in UFOs. She was strong earthbound person. I only believe what I see, feel, touch. Anything else is nonsense, blah, 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 blah. And so I said, well, what did you think? And she said, all I could think of was I was scared. And she won't talk about it.
Wow.
She just won't talk about it. That's the way she handles it. So I says, well, I guess that's not an airplane. It's not a dirigible. It's not a hot air balloon. It's not a jet. We heard no engines. It was perfectly silent. So I made it clear. I says, you're looking at a starship from another world. Very few people actually ever get to see one up close like this. It was less than 100 yards from where we were standing.
Wow. That's, yeah. I mean, that's definitely a life changer. It's to kind of bring it back around. Are you pretty much self-taught in the
Yeah,
physics? Yeah. I
yeah,
mean, and
pretty
you
much.
that's not on purpose. You felt like almost like a calling toward this, right? Towards physics.
Yeah, it started when I was young. I've talked about it before on other shows. Basically, I had an experience with, when I was 10, with the nuns in the catechism class asked us to find a saint born on our birthday, the kids in the class. So I went home and there was no internet in 1965. So I asked my parents, do you know of any saints born on March 14th? And they didn't. And so I went over to the calendar, and as fate would have it, on that day, they were celebrating Albert Einstein's birthday on March 14th. So I said, well, I'll go look him up. And I had the encyclopedia and I looked up Einstein and I read about him. And I was fascinated by that. And then I went on and read some more, and I discovered the unified field theory that was also written in it. And for some reason, I seem to remember James Clerk Maxwell wrote that article, but I'm not sure now. But at any rate, when I read that, I said, boy, this really makes sense. I'm not sure if it was Einstein that had put that article in or James Clerk Maxwell, but I associated, Einstein to the unified field theory as was done by science and the newspapers and the TV thereafter, because that was his big quest. And, I became involved in that. I thought over the years, I'll just keep reading about it, and eventually somebody will figure it out, and I'll read about it, and I'll learn, I'll know. I never thought it was really going to be me. I always thought I had good ideas about it, mainly coming from Einstein, but I, I didn't really see that coming, that, all of a sudden I would complete a book and then I'd look at what I wrote and I says, this this looks a lot like a unified field theory.
Wow. That is, oh, that just blows my mind. It's just crazy. Do you work with a team or are you just by yourself?
I primarily work by myself, but along the way, in doing shows like this, I've started to meet some people, which is very good.
That's
I'm
cool.
working with somebody who programs supercomputers. He's doing some animations for me.
Wow.
Um, I actually hired a physicist to train me in the math that I chose to explain gravity. I just by talking with other physicists and stuff, and I had this model in my head. I was able to finally find some math that matches the model, the physical model. You have to have the right model in order to derive the equations, in order to describe reality. If you
Right.
don't have that, that's what Einstein always did. He kind of got away from that idea a little bit, not much, a little bit in general relativity, but because he was always doing mind experiments, and these mind experiments were revealing how the world mechanically worked. No magic quantum mechanics stuff going on. It was Newtonian kind of mechanics, stresses and tensions in a material and in the ether. And he always worked from that. And I adopted it. I fully accepted that was correct. I just had to fine tune what was done. I had to extend it a little more. So, and I have hired a physicist to help me derive some old equations so that I could understand them to a deep level, enough to write about them and use them to solve for mass, which I succeeded in doing. So I'm in the final stages of writing, which is going to be a fairly large paper, larger than most physicists. Usually they're 8, 10 pages. Mine is going to be between 60 to 80 pages in length, because I do a lot of building. I'm like in a court of law, and I'm making a case for things they don't believe in. And
Right.
I'm proving the ether exists, and I'm proving how you manipulate it, moving particles to create the fields of force. And then once I've established all that beyond any reasonable doubt, then I'm going to give the equations, and it's a system of equations, fairly simple. It had to be, or I'd have never solved it, because I'm not a great mathematician by any means. And it all works. and it works according to my model. So I back up my model in here in my mind with the math, and it's
Right.
all going to be out there. And it's just a matter of them seeing it, reading it, understanding it, which I'm sure they'll be able to, and accepting it, because it will mean, in many ways, it'll mean the end of quantum mechanics as the road to the theory of everything.
Really.
They'll realize it's nothing more than a very unique, special tool that can help you get right answers in certain situations. But quantum mechanics will never, ever be able to explain how things work. And that is its weak underbelly. And you got to use the mathematics and differential equations of Newton and Einstein and Lorentz to describe how the world mechanically works. And so basically, I've gone back to the future. I'm taking out
Nice.
some things from the
That's
past,
so cool.
but these are the correct things, and the things that we abandon are correct. And now I'm resetting everybody and saying, basically, this is right, this isn't. While you could use quantum mechanics, if you want to bang particles together and figure out if you can get this one or that one, that's fine. Quantum mechanics is great for that. But it's not a theory of everything. It's just like a toolbox
Okay.
of equations that are used to, calculate, the probabilities. Probabilities don't make things happen. There's no such thing as a force, a probability. Real forces, action at a distance, is caused by stresses and tensions in the material substance that we're all made of and within. And until we get back to that, which I have done using a second rank tensor formula, which, by the way, I didn't know was that until I was reading a book about Einstein, and he predicted, says the person that'll find it, it will be a rank 2 tensor. So I'm reading this book and I say, get excited. I wonder if my equation is a rank 2 tensor. So I started asking around on the internet, and sure enough, it's the prime example of a rank 2 tensor.
I'm so
So
happy.
Einstein
Honestly,
was right again.
I'm so happy for you. Honestly, I mean, I know I don't know you from Adam, but just seeing this and seeing people like yourself, and it gives me hope. And people like somebody, it's going to be somebody like you, who's going
Yeah,
to crack. I mean, I know, cliche, what, but seriously, I mean, it's just it takes balls to do that, and it takes a long time. Like I've thought about trying to build these things in my house, getting some magnets, and I thought in
yeah,
frequencies and everything like that. And have
yeah.
you ever? What about frequencies? You ever? Frequencies are part of the equation, or no?
Yes, yeah, that's what I said. Remember, I said
Around,
the
yeah.
rotation, that's a frequency,
Okay.
right? Something that rotates revolutions per minute, it equates to a frequency,
Like
10,000
radio?
cycles. Yes, yeah, yes and no. Well, a radio is a frequency, you got a sine wave, right? And you've
Yeah.
got a photon, which is part positive charge and part negative charge. And it's at different frequencies. That's the electromagnetic spectrum. The shorter the frequency, the higher the energy. The longer the frequency, the lower the energy. And it's just a longer or shorter
Okay.
wave.
Gotcha.
And that's a frequency, but that can be that's a kind of, we're looking at a two-dimensional kind of thing. But there's rotational frequency, which is what I think is going to lead to the big breakthrough. Magnetic fields in motion enhance the anti-gravity effect. Now, how do we find out how much? We need to start doing experiments. We need, empirical data. We need
And that's finite too. I mean, you have to be so precise when it comes down to that, right? I mean, there's no getting by.
well,
There's
that's
no
what, the scientists are really good at that stuff, the physicists to do all these experiments, the experimentalists,
right.
they're very precise and very careful, not to get tricked by systemic failures or whatever. And they'll keep doing it and try to quantify this and measure that. And then they'll put the math to match what they found. And so what I'm doing is giving them part of the math, a very important part, because
Okay.
it's at the very base or foundation of reality. And part of that discovery also comes from a near-death experience, not mine, somebody else's, who I talk about in the book, and how I got the frequency, I guess you could call it. It's certainly part frequency, which is the animation I'm making right now, which is very hard to do. And so I'm glad I found this fellow. I'm not sure if I should give his name yet or not.
That's fine.
I don't want to get him in
It'll
trouble.
come. It'll come out when it needs to.
I'm giving him credit in my, it'll be in my paper, this animation that I'm putting, which I call the signature of God. And it's at the heart of how the neutron and proton work. I mean, it explains not only how they get their mass, but it also explains the binding force, which is completely different explanation that's given by quantum mechanics, which I'm going to basically disprove. And I feel bad about that. And I know a lot of people are going to get upset about that, but the binding force becomes so clear and apparent when you see this animation. It says, oh, of course, that's why they stay together. Those corks don't come out of there. It makes perfect sense. And so I got a lot of hurdles to cross. And I think at some point there's going to be a lot of mad physicists out there, but I'm hoping that there are some open-minded people as well, physicists, and I think there are. And if I can reach them, enough of them, and get them to join me at some point, there's a great chance that we'll have anti-gravity. Because once you get to the whole thing, okay, he's got gravity figured out. Let's listen to him on anti-gravity. I think he's got, kind of a jump on the rest of us there. So let's do what he says there. And which I don't think I'll have a problem, because the people who are willing to do anti-gravity are not really mainstream scientists. They're the guys, they're your alternate theory guys. And so I think I'll be able to get some people to do that kind of work. And I'm working in that direction as well.
I'm so excited. I can't wait. Just one more thing before I let you go. Is entanglement part of quantum mechanics?
It's part of quantum mechanics, but it's a misinterpretation of reality. It's a tricky little beast. I wrote a letter to somebody. I don't think it was you. Was it you that I wrote the letter explaining
No, sir.
entanglement? Okay.
No, sir.
So let's go over that for a second.
If you don't mind.
No rush. It hasn't even been an hour yet. So if you want to go an hour and a half, that's fine.
That's great.
I have no problem with that.
Thank you.
No, entanglement. What an interesting story. It's really an interesting story. Is that Albert Einstein was going through quantum mechanics, basically the theory, the Copenhagen interpretation, looking for defects, something that he could use as a wedge to get into it and say, this is an incomplete theory. It's wrong here or wrong there. And he came upon the entanglement explanations, and they sort of implied that if you have this certain situation, that there's going to be a spooky action at a distance connection. Somehow those particles, according to the theory of quantum mechanics, the Copenhagen interpretation says basically there's a connection there, an instantaneous connection. And when you look at one, it will define, when you look at the one twin particle, the other one will be the, let's say the polarizations. One will be this way, the other one will be that way. As soon as you look at this one, the other one becomes the truth, and the opposite, basically. So there's a correlation there. And so he said, well, that can't be true, because somehow that when you look at the one, you're telling the other one how to be oriented. And that means there's some sort of spooky action at a distance communication going on. And they bid on it and said, okay, well, maybe that's true. Let's do the experiment. Eventually they did, and they found out it seems to be true, because the quantum mechanics equations match better than the regular probability equations, only because they account for the field theory better than the normal statistics that are involved. It's just a very little difference, but I think there's a higher than expected correlation going on, which I feel is in part caused by, you know, they pass the photons, let's say, that they're experimenting with and detecting through polarizers. Well, you're changing the thing you're measuring now. And so that should kind of invalidate
Right.
the experiment, because you may not want to admit you're doing that, but when you pass a photon, its orientation, I will guarantee you, changes. And so it gives you a higher than normal correlation. That's one problem. Another problem is the correlation was created at the beginning of the experiment when you created the twin particles. And so it basically was there the whole time. And so reading one and getting the other one, that's not really affecting the other one. But
Right.
in the theory, they're saying it does. And so that's a misinterpretation, a bad assumption that everybody's bought into. And so now scientists, a lot of them like to talk about that spooky action at a distance,
Mhm.
a superluminal connection. It's another rabbit hole.
A magician's dream.
Yeah, it's not, it's just made things worse.
I
Because
heard you
it
say
kind
that.
of
Yeah.
validates quantum mechanics, because that equation, again, when you're doing high numbers of measurements in the millions, and you have a set of equations that very accurately predicts that averaging to where you get to 8, 10, 12 decimal places of accuracy, that's being interpreted as somehow meaning that means these equations are determining it's the math somehow, in some abstract magical way that's determining the outcome. The particles are choosing there's a lot of bad ideas in quantum mechanics. When you talk about the field theory and the interpretations, they just don't make sense, and they know they don't make sense. And this is just another example of getting explanations that don't make sense, and they say, well, that's just the way it is.
See,
And we don't care if it doesn't make sense.
that's so weird, because I watched do you know who Lou Elizondo is?
Yeah.
Okay, well, I heard him say on a program, The Basement Office, amazing. I don't know if you ever seen it, but a reporter named Stephen Greensheet. Anyway, he was describing basically what we were seeing with the Tic Tac and everything was explained by what is it, quantum mechanics, in a sense. Basically, a dog walks in the box and out 5 minutes later 2 cats walk out, kind of deal. Does that make any sense to you, or just can you put two and two together with that, or is that still just kind of making sense of just basically telling
I
you
would
how it
have to
is?
see the whole explanation to get
Okay.
it in context to
Right.
understand. Is that what you just said doesn't make any sense to me?
All right.
It sounds a little bit like a Schrodinger's cat kind of explanation, which also was put forward to explain that there's something wrong in quantum mechanics, because basically it doesn't make sense. Just because you don't know the state of the cat, whether it's alive or dead in the box, doesn't mean that the cat is both alive and dead in the box, or doesn't mean it doesn't have any state at all. These are some of the quirky little explanations. Well, we can't determine it until we measure it, and somehow measuring it determines it. No. That's what Einstein kept saying. It's already determined. I don't care if you can't determine it before measuring it. That doesn't mean that it's not there. It doesn't mean that there isn't an objective reality, which is what Einstein kept trying to drive home that point. There is an objective reality that exists. If you turn your back on the moon, it doesn't stop existing just because you're not observing it.
Yeah,
And,
I've heard that a lot
and
lately.
it just, I don't know what Lou was talking about, where you put a dog in, you get 2 cats on it.
All right, that was unfair. You're right, it was totally. I just thought maybe you had seen it, or hopefully you're just. But what was I just going to say? Do you need a whole? How help me understand how you get all that mass down, because you need a lot of mass to affect gravity, correct? Like with the on the level we're talking about? Is that where the magnets come in to produce that amount of mass?
No, mass comes about. I have a definition here from super relativity, the gravity explanation. Gravity or mass, either one. Gravity is caused by the accelerated motion of fundamental unbalanced charges. When charges move in this way, they cause the space in and around the particle to contract. Gravity is a contraction of the spatial medium. So I said some key words. Each one of these words is vitally important. You can think of this sentence like an equation. Gravity is caused by the accelerated motion of fundamental unbalanced charges. Every one of those words in there is vitally important to understanding how gravity works. Unbalanced charges are like electrons. Any charge that's unbalanced, either positively or negatively, tends to move in an arc or has angular momentum, like the electron in an orbital, like the quarks inside of the neutron and the proton. They're moving in a highly accelerated fashion. This type of circular motion is accelerated motion. It's uniform accelerated motion. And Einstein, see, you got to link things together. And that's what I did. He kept saying, somehow gravity is the same as acceleration. It's the equivalence principle. Newton was the first one, maybe even Galileo before them, associated acceleration with gravity, but they didn't know the mechanical link. What I'm bringing forward is the mechanical link, the origin of mass. So what I'm saying is accelerated motion of these particles creates mass, and I'm telling you how it's done, because those motion through space in this
At a highly vibrated state, right? It's gotta be highly.
The faster, the more the greater the effect.
Gotcha. Sorry, I didn't mean to interrupt. Sorry.
Yeah, so like the quarks inside of the neutron and proton,
All right.
they're moving, I calculated, at over 99% the speed of light in a very confined space. So there's going to be a highly accelerated motion. So, and it's because they're so small and their charges are so small, you get just a little bending, but it's additive. So if you start putting, one proton next to another, next to a neutron, pretty soon, all these little bits of contraction of space are adding together, condensing into a very small area, and you have mass, which is basically particles emitting a gravitational field.
Wow.
And so there must be some way, something that they're interacting with that causes that. And that's been the very big mystery, is that, if you go to quantum mechanics, you get like a half a dozen different explanations for mass. None of them right, other than whenever they talk about inertial mass, which is what I'm saying is the total explanation is inertial mass. There is no such thing as rest mass. If something doesn't move, there's no gravity. Let me give you this example. If we could stop the quarks inside of the neutron, let's say, we somehow magically could stop them, the mass of that particle will evaporate. And not only that, but the magnetic fields around the electromagnetic devices would dissipate. All you would do is have charge. And in my book and in my theory, I explain that it's all about motion and how charges, the very basic fundamental things of this world, of this universe, are just nothing but vortexes or twists of space. They look a lot like this thing. Here, I gotta find the camera. See how they twist around like that?
Yeah.
That would be an electron right there. And because they're this way, you have a very small twist here, and as you get to the other end, it's more twisted, it's more stretched. You create a pressure gradient along from this point to this point, and it gets less and less pressure as you go this way because you twist more and more. So that's what you need for motion. You need a pressure gradient. So I go into great detail in my book describing all the things that move because of pressure difference. You look to nature to find the patterns to explain what's going on in the world that we can't really see directly. And in every case, if you want to know what causes motion, you'll find that it's pressure. Pressure causes water to move in a hose. Pressure causes the wind to blow, and the weather changes. High and low pressure systems cause the winds to blow. Airplane lift, that's because of pressure, higher pressure on the bottom of the wing and lower pressure on the top of the wing. Combustion in the combustion motor, the pressure causes the pistons to turn, which causes the crankshaft to go. Pressure, pressure, pressure is the cause of motion. And like Einstein said, nothing happens until something moves. People don't get how deep that statement was. He knew what he was talking about. It was an incredibly deep statement that just went over everybody's head.
Say it again.
Nothing happens unless something moves, because you don't get a magnetic field unless this thing is moving and spinning. Since it's a twist of space and it moves,
looks like a
through
vortex.
space, yeah, like a vortex. And then there was a vortex theory back in Maxwell's time. They were very interested in it. And at first, when I read about it, I thought, what are these guys? Where did they get this from? And the more I thought about it, I says, that makes sense. There's only so many ways you can deform space. You could twist it clockwise, you can twist it counterclockwise, you can stretch it, and you can contract it. That's pretty much all you can do to it. And sure enough, when we look in nature, we find negative charges are, I think they're counterclockwise, and positive charges are clockwise. And you see there's motions in the lines of force going either inward or outward. So what I'm saying is it's all mechanical. This is not, mysterious probabilities here that causing the motion of particles. You can't even use that. If you use quantum mechanics, they'll tell you particles don't have paths. They don't have velocities. It's just probability clouds. That's nonsense. And we got to stop that. Because if you go to a cloud chamber and you look at the particles zipping through the clouds, you can clearly see they have a path and a velocity. You can see it. Why are you denying it? And that's not a probability motion you're seeing in the cloud chamber. And they don't use probabilities to propel particles around in the CERN particle accelerator. They're using magnetic fields to carry and push the particles all the way around. That means those particles have a path and a location the whole way around, and they use the calculations to calculate so that they collide in the detector. And that's everything, not so much to do with probabilities, and a whole lot to do with ordinary classical physics. And they got to be reined in. I hate that I got to be the one to do it, but somebody's got to do it.
Are they set in their ways? Are they set in their ways, or is there a different, kind of more evil thing behind it? I mean, what's the deal?
It's not an evil thing. Scientists are blinded by their own presuppositions.
Wow, that stinks. That stinks for everybody else.
Well, they're the experts, and we're counting on them to get this stuff right. And when they say, this is what we think is right, don't talk back. Don't ask questions. What do? We usually get quiet and we don't say anything. Well, this guy isn't going to be quiet. And I'm going to keep driving home this thing until I don't take any more breath in this world. And hopefully I can get it through, because mankind benefits greatly by the use of anti-gravity and knowing how this universe really works. And there's just tremendous resources being wasted on quantum mechanics theory. I mean, everybody's in it. And it's like Richard Feynman said, what if everybody you knew that's ever worked on this problem thought it was this way was wrong? The whole idea, the whole model was wrong. How would you even know? You keep trying to do it. They've failed 26 times to use a particle-to-particle gravity theory, the graviton. It's never been found. They won't stop looking for it. And eventually what they're going to do is make up an excuse for why they can't find it. And they're going to start doing more experiments like they did with the Higgs. They never actually saw the Higgs particle. All they saw is what they thought the products of that particle would be if it existed, because it didn't even live long enough to get to the detector. So we don't really know. I mean, they gave a Nobel Prize. They say, oh, we all say we saw it. We really didn't, but we saw what it split into after, sort of, you know, but that could have been something else that caused that. But we're going to call it the Higgs, and we're going to, you know, have a champagne party, and because that's what they do. That's how they make their living, by finding particles. And so, you know, everybody wants to have a big success, and we got machinery, and we have the mathematics. And so they've gotten into a paradigm where this is what physics is. You find particles, you theorize new ones. And the only way to get new ones is to build bigger and bigger machines to find just a few more particles, which are more and more short-lived. So maybe the new future is going to be, well, we don't see these particles anymore, but we have their progeny that, you know, comes from, you know, it never did make it to the detector, but we think if it would have, it would split into these, which we did see. And it's not good science. I mean, there's other things going on. In my book, I go about here. This is a disgrace. The speed of light is slowing down. Now, when I was working on my theory, I says, look, the speed of light can't be constant, really, because it's determined by something else. So if you change that something else, permittivity and permeability, or the density of space, if you change that, speed of light will slow down or speed up. And sure enough, if you put a beam of light through a gravitational field, it slows down. They know this. This is a scientific fact. But they'll want to argue with it. Well, it's not really slowing down, only if you're looking at it from another frame of reference. Well, yeah, that's true, but it slows down.
Right.
And
You're skewing it one way.
Yeah. So I began looking for evidence to see if anybody knows the speed of light is changing. And I found the guy. And he, what's his name? His name is Barry Setterfield. And he did some statistical analysis of all the measurements starting from 1729 until today. They've measured the speed of light many, many times, and he noticed over time the number kept dropping. So, you know, of course, he got fairly excited, even in some cases where they were using the same exact equipment, waited a few years, measured it again the same exact way, and found that it was a little bit slower now. And that makes perfect sense in my theory, because I says, well, okay, let's say Barry is right. We're slowing down. That means we're headed toward a gravitational field, a very big one, a very strong one. So then I went and said, okay, I accept Barry's idea. I think he's right. I think the speed of light is slowing down, and it's what the astronomers from Hubble in that time about the expanding universe is wrong. It's not expanding. There are universes that are accelerating away from us as we go further out, and as a general rule. But that acceleration, what's linked with acceleration? Not a mysterious force we've never discovered called dark energy, which we don't know exists, and has never been proven, experimentally proven. So instead of assuming something that makes no sense without any scientific proof or evidence or theory, I said that acceleration from those things is coming from gravity. They're falling towards something. And the further they get from us, the closer they are to the thing they're falling toward. So I began to look for gigantic black holes in the universe. And those things are what are attracting other things. So I thought, well, I'll go look for it. And I found an astronomer that was talking about it. They did a lot more measurements. And they found the whole universe, there's these gigantic Titan-sized black holes in different areas in the universe. And there's hundreds of galaxies. Our galaxy group is falling toward something called the Great Attractor. And this thing is a massive black spot out ahead of us. If you look at the Milky Way at night, and as you look through it toward the other side, that's where it's headed right now. That's where our galaxy, Andromeda, and several hundred others are all going, and they're not going away from each other. Andromeda and Milky Way are actually coming together. So that's kind of against the old Hubble theory where everything is pulling away.
Right.
They're going as a group towards something really big.
But wait, what if say what if the Milky Way happened to be just traveling a little bit faster than Andromeda? So that could cause our two galaxies to collide, correct? Or in the galaxy, everything's
Well, if
traveling
it's
the same-
ahead of us,
Right.
and it could be very well like the one ahead is always going to be going a little faster because it's closer, so it's going to be accelerating more.
Okay.
But I'm thinking ours are more parallel, and they're heading toward this thing, and they're going to eventually collide on the way to colliding with the dark thing.
All so they're going like this, all to like one point in the
They're all
universe.
moving toward this, and
One
eventually
point.
we're going to collide because we're kind
Ah.
of maybe in the same plane, laterally speaking.
Gotcha.
But they're definitely moving closer together, and
Right.
either we're catching one, or I think it's more like we're kind of parallel and moving toward each other.
Sure.
And they're going
I
to
see it.
collide.
Sure.
But that's probably not going to happen much before the collision into the great attractor, which is going to be a massive black hole that's going to be hundreds of light years apart. And that explains perfectly why the speed of light slowing down. We're moving at about 1 million miles an hour toward this thing. And over time, the gravitational field is getting stronger and stronger and stronger. And as it gets stronger, because gravity goes out infinitely far, there's no end to it. You'll get some effect. So as we get closer and we keep measuring the speed of light, you'll see it gets slower and slower. It's like a clock ticking down. Click, 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 until when speed of light hits zero, you know what happens then? We're going into the event horizon and it's over. So if we don't figure out how to get off this planet in the next 5 billion years or so, it's going to end. And that's assuming that the sun doesn't burn out first and fry us. So, they're not like it's urgent
Right.
that we need to develop it, but at some point, you never know. And I talk about it in the book. You never know what's going to happen in this planet. We could be hit by another huge asteroid tomorrow. And if we don't have a way to get off this planet, it's over for the human race and everything else on this planet. So this is a matter of survival.
Sure.
We have to achieve greater than light speed travel in order to colonize somewhere else to perpetuate our species until the end of the universal cycle.
Well, what if it's not about trying to get as fast as speed of light? What if it's about dimension hopping, or tearing that hole in the fabric of space, time, and dimension?
That's where the Stargate comes in.
Right. Exactly. Yeah. Back to So, and I tell you what,
you could do that maybe as well.
Sure.
Some aliens are using that, but obviously there's plenty of them that are using the interstellar spacecraft because they got here, didn't they?
Sure did.
And they sure didn't do it using rockets, and they didn't do it going just at the speed of light because it's too slow. The nearest star to us is Proxima Centauri, 4.2 light years. If they're just going at the speed of light, it would take 4.2 years to get here one way. That's intolerable. But that won't work for us.
But hey, at least we'll have 8 minutes till when the sun explodes. We'll have 8 minutes to run and hide, right?
That's right. It's about 8.5 minutes away, the light from when it gets here.
My gosh.
But there's things that are being covered up. We're not even measuring the speed of light anymore. Now, since about the 70s, the dropping of the speed of the light stopped. Well, that's interesting. Why is that? So I got suspicious. I didn't just accept that it stopped dropping. I said, there's got to be an explanation for this. And I found it on Quora. Somebody asked, how do we measure the speed of light? And I found that back Actually, the whole problem started with Raymond Burge, I think was his name. Um, Yeah, Raymond Burge, the chairman of the physics department at the University of California, Berkeley, in 1929, established the atomic constants. And at this time, all the way up until the 40s, they were measuring the speed of light. Damn it, it was slowing down and was pissing everybody off because Einstein said it's constant. And is bad for science to say otherwise. So we had to do something about it. So Burge declared the speed of light one number. It says, look, from now on, we're using this number, okay? So if you don't get that number, you tweak your equipment. You move it a little closer, or a little farther, whatever you do, so you get it to this number. And
That's so
then you
bad.
start making your measurements. So what we're doing is changing the distance of the meter to accommodate the number we chose. So of course, when we did that, we no longer get a slower speed of light because we just tune the equipment to get the number that Raymond Burge picked.
And with those numbers, just a little bit off, it's a lot, right? I mean, just
Yeah.
you can't do that. And that's so sad to hear something like that, because that's
So,
not the way science is
the way
supposed to
we
be.
measure it now, and I've checked with other guys, and they go by this because they don't want to rock the boat. Because if
Right.
you say the speed of light is changing or something like those guys did with the neutrinos, they got fired. They were destroyed.
Right. It's just same thing with the pilots and the way the pilots and the UFOs back then. It's the same kind of principle, but well, hopefully times are changing. It looks like hopefully they are. And I asked Nick Pope, I said, what do you think it is? I said, you just think it's a whole bunch of old dudes at the top, we're just waiting for them to die. He says, that's not a bad assessment, basically. But he said, but you got to remember, there's a spry young dude right behind that guy, who didn't get there by being nice. You know what I
Yeah.
mean? So I don't know, man. But I tell you what, that super hyphen relativity website is really, really cool. I enjoy that. That's your website, right?
Yes.
It's cool. I enjoyed it. I'm going as
Thank
soon as
you.
we're done this, I'm going to go right back on there. And I'm ordering I'm going to tell my wife to get me your book for Father's Day. It's going to make a great Father's Day gift. I
Nice.
can't wait. So
Well, I'm going to come out with another book after I finish all these papers I'm doing. And
when's your report come out? Do you have a date, or when's your paper come out? Or is there a date or anything? Or
it's a few weeks. I've kind of gotten slowed up. Like there's been a lot of stuff going on at my house that I want to get into.
right by a
um,
few weeks? Oh wow, that's great news. Then I was
yeah, it's
thinking we
not
have to wait.
far off because the math is done. I'm putting that part in, and I have to go through and edit. I edit stuff like crazy. I want to say exactly the right thing, and so it's
Sure.
mostly written, but it's got to be edited, and I might edit each paragraph 10 times. And when I get it done, when I'm happy with it, then I'm going to upload it. And if you know of any places, like all I got is Wiki, which I can't really do myself. I guess the rules are such. It's too bad because I'm the one that knows the most about my own theory.
Right.
So I'm not sure how I'm going to work that, but there's ResearchGate that'll accept papers by people like me who don't have advanced degrees in physics or whatever. But I need places like that to upload it to, journals, science journals. So if you know any, please forward those journals to me, and I will approach them and try to upload to them.
Okay.
So I'm looking for places, magazines, journals, whatever, that are interested in this particular article.
And they anybody watches, they can get in contact you with a super hyphen relativity.com, right?
Yeah, there's a thing where you sign up, you subscribe. I get an email, and then I will respond back from my email to you. So
Okay.
anybody who has questions or wants to,
Or help you with your question, and you getting this out there. So Mark,
yeah.
I appreciate, I honestly do. I mean, I wish you were my next door neighbor. I mean, honestly, I'd be coming over every day, man. I would.
You sit by the pool and have some beers and talk about all this stuff. It's
I was
great. It's fun. I enjoy doing it.
It's not only fun, but it's important. And like
It
I
is
said, it's
vitally
super
important.
important. Exactly. So, and it's good stuff. And I appreciate it. And you're out there a lot. I've been looking, and you're out there a lot, which is great news. Just, and of course, your book.
It's been tasked to me. This is what I have to do. This is what
Wow.
I was sent to do. And
Wow.
I'm going to do it to the best of my ability and try not to let the world down on this thing. Somebody's got to do it. I guess I'm the guy that got picked to do it. So I just gotta, it would be nice to be retired and just go fishing all the time and do that stuff, which is part of me would love to do, but
Wow.
I've got this information and it would be wrong just to just write a book and then, go fishing. So,
Right.
I got to go out and talk to as many people that will listen so that, we can start building starships and improving the world.
Well, I can't wait till you come up 95. I'm right here in Maryland. So when you come up close,
Ah,
I can't wait, man. I can't wait to see you in person. So again, Mark, thank you not only for coming on the program, but thank you so much for you do and all the time you spent on it. And like it's super important. And I'm so grateful that I had the opportunity to talk to you. I mean that, I honestly do. And thank
Thank
you
you.
so much for your time, Mark.
Been a pleasure. Great.
Take care
Appreciate
of
it.
yourself, brother. And I hope to talk to you very soon.
Okay, thanks.
Take care.
Bye.